For my player footsteps, I created a switch group for each surface material in the game. I then rendered each footstep sample into its assigned render container. For each surface, there are a set of walk and run samples, which are connected to movement speed switches. In Unity, I created a surface switch script that assigns a surface material switch to the player footstep sound whenever the player walks on that particular game object. Some prefabs contain multiple materials, so these are assigned individually. After creating the footstep function in the player controller, I then added switches that were triggered by the movement speed settings. To create an adaptive gun sound, I designed 4 separate components to the gun sound. Mech defines the mechanical sounds of the gun firing, noise represents the bullet firing, sub is the low frequency impact, and the tail is the sound of the gun in the surrounding environment. For the tail, I created a switch container for indoor and outdoor gunshot sounds. These switches are defined by a room script, attached to each room, that tells Wwise whether the player is inside or not. This enables the gunshot to be more interactive with the environment. The gun scope is triggered using the scope script on the weapons holder, called when the right mouse button is pressed. The script also triggers events and states in Wwise that correspond to the scope being used or not. The scope states in Wwise are used to reduce the volume of music and ambient sounds and bring the volume of the enemy sounds up, so that the player can focus on localizing the enemy in the scope state. The scope state also increases the volume of the near-field gun layers and reduces the tail layer in order to achieve a more detailed and impactful gunshot. In the main gun script, a ray trace is used to determine which object the gun is firing at. If the bullet is fired at an object that contains the surface script used by the player footsteps, then a collider sound event assigned to that object switch will be played. Because the collision sounds are 3D, attenuation and positioning processing is also assigned. My enemy characters are created using models and animations from Mixer Mode. After rigging each animation to the model in Unity, I started to assign footstep events to my animations. In order to call footsteps from the animations, I first had to create a footstep function in the enemy controller script that called the footstep event. Then, using the animation event, I could call that function. In the Animator tab, I connected each animation state using Boolean and action transitions. These transitions are called from the enemy controller script, depending on the current state of the enemy. In Reaper, I edited a screen capture of each animation into regions, before recording my partner perform the zombie sounds. I then edited these sounds with effects and aligned them to match their animation regions, before rendering them into Wwise using the Wappy transfer. Because the patrol and chase events loop, I used a seek event to ensure that the loop was randomly offset each time it was called. I also created stop events that were triggered by the newest play event. Therefore, if the enemy switched from patrol to chase, the chase event would automatically stop the patrol event. There are a few menus in the game that contain interactable objects such as buttons and sliders. For the music and reverb slider, I created a script that could transfer each slider value as an RTPC and Wwise. This allowed the player to turn down the music and reverb during gameplay. For the buttons and toggle, I created a script that gets assigned to each UI element, calling a Wwise event whenever the cursor hovers over or clicks the item. I then recorded a screen capture of the UI elements and used this as a reference for the sound design in Reaper. Once the UI sounds were in Wwise, I added randomization to the pitch and volume and generated the UI sound bank.